today we will explain about tree in a graph. Okay, so what is tree? A connected graph having no circuits is called a tree. It means in a graph no loop and no parallel edge. So this is called tree. For example, this is a tree of one vertex. This is a tree of two vertex. This is a tree of three vertex. Okay, and similarly. So this is very easy to explain about tree. Now I am going to explain properties of tree. Okay, so first property is one and only one path between every pair of vertices. So first property is one and only one path between every pair of vertices. Like for this tree, one path. There are three vertices. So between any two vertices, one and only one path. Here, between any two vertices, one and only one path. Okay. Next property is a tree with n vertices has n minus 1 edges. It means here two vertices, one edge, three vertices, two edges, four vertices, three edges. Okay, so in general, a tree with n vertices has n minus 1 edges. Next property is a graph is a tree if and only if it is minimally connected. A graph is a tree if and only if it is minimally connected. It means for any two vertices, only one path. Okay, it means minimally connected. So these are important properties of tree. Okay, now next definition, forest. As we know, collection of tree. Okay, so definition of forest, a collection of disjoint trees is called a forest. What is disjoint? Meaning of disjoint means we have two sets A and B are disjoint if they have no any common element. So in a similar fashion, two trees are disjoint. Also we have, so collection of disjoint trees is called forest. Okay. Now leaf. What is leaf? So a vertex is called leaf if its degree is 1. It means a vertex of degree 1 in a tree is called leaf. Okay. Next definition is branch. So a vertex of degree more than 1 is called branch. So this is the definition of branch. Rooted tree. Now what is rooted tree? So a tree in which one vertex is distinguished from all the other vertices, this is called rooted tree. Okay, so as we know, in a tree there are so many vertices, but if this tree is rooted, then one vertex is distinguished from all the other vertices. Okay, for example, this is rooted tree. Okay, this is rooted tree. This vertex is distinguished from other. Also, distinguished vertices is denoted by this triangle. Some authors also denoted by triangle. Okay, so this is rooted tree. Okay, this is rooted tree. This is rooted tree. Okay, now directed tree. So as we know, in a graph is said to be directed if each edge assigned with a given direction. So similarly, in a tree, if each edge assigned with a direction, then this tree is called directed tree. Okay, so this is a directed tree. means each edge assigned with direction. So a tree in which each is assigned with given direction, this is called root directed tree. Okay. Now sorting tree. What is sorting tree? So sorting tree is also called decision tree. So what is definition? So decision tree is a rooted tree. Decision tree is a rooted tree which is used to obtain the solution of any problem. Very important. Sorting tree is very important. Means what is sorting tree or decision tree? So sorting tree is a rooted tree which is used to obtain the solution of any problem. For example, this is rooted sorting tree. This is sorting tree. Now we will explain binary tree. So a binary tree is a special type of rooted tree in which the root is of the degree 2 and the rest of the vertices either of degree 3 or 1. Okay, so this is rooted tree. For example, this is a rooted tree. Okay, so root of degree 2. Okay, and other vertices have degree 1 or 3, like degree of this vertex is 1, degree of this vertex is 3, 1 2 3, this vertex is 3, this vertex is 1. So this is a binary tree of 9 vertices. Okay, you can see also here this is a rooted tree but not binary because degree of root is not 2. Here this root has degree 3, this root has degree 1. Okay, so this is not a binary tree. Every binary tree is a rooted tree, but converse is not true. Okay, every binary tree is a rooted tree. Now label. What is label? The label of a vertex V in a rooted tree is the length of the unique path from the root to the vertex. Okay. Label means the label of a vertex V in a rooted tree is the length of the unique path from the root of this vertex. Okay. Suppose this is a binary tree. So label of root is 0 and we can calculate label of any vertices means how many edges, okay, from root to the vertex. So we shall count and the number of edges is label. Okay, the label of root is 0. This is root, so label of root is 0. This is important remark. Now, height. The height of a rooted tree is the maximum of the leaves of vertices. Okay? In other words, we can count how many edges from root to the vertex. So this is height. So I am going to give an example to calculate label and height. Okay, so this is a graph. Okay, so this is a binary tree, rooted tree. This is a rooted tree. So V1, V2, V3, V4, V5, V6, V7, V8, V9, V10, V11, V12, V13, V14. So vertex, so label of this V1 is 0. V1, after V1, V2, V3, V4 is 1. Why? Because from this root number of is 1. 1. Similarly, if we count V6, V7, V8, so first we will count from V1. So 1, 2, 1, 2, 1, 2. Okay, so 2. Similarly, this is very easy to calculate height of other level of other vertices. And what is height? So maximum number of is, which is 3. So the height of this tree is 3. Distance between two vertices. So we have studied in a graph distance between two vertices. So minimum number of edges between two vertices is called distance between two vertices. Okay, so suppose this is a graph. Okay, so distance between any two vertices. So first we will count number of edges. So there are so many paths. So minimum number of edges means shortest path between two vertices. This is called distance. For example, this is a graph or tree. So distance between any vertices v1 V4 1, V1 V2 1, V1 V3 1 2, so 2. Okay, V1 to V7 1 2 3, so 3. So this is the distance. This is very easy. Now eccentricity of a vertex. So here we calculate eccentricity for each and every vertex. Okay, so what is the definition? So first we calculate distance from this vertex to each vertices. Okay, and what is the maximum length? This is called eccentricity. It means eccentricity of v is equal to maximum of distance between v and vi. Vi means vi is each vertices of capital V. Okay, so this is eccentricity. For example, in this graph, we calculate eccentricity of each vertex. For time being, if eccentricity of V1, so EV1 is equal to maximum of D V1 V2, V1 V3, V1 V4, V1 V5, V1 V6, V1 V7. So first we calculate distance between V1 and other vertices. So this is 1, 2, 1, 2, 3, 3. So maximum of this number is 3. So eccentricity of V1 is 3. Similarly, you can calculate eccentricity of V2, V3 up to V7. Okay. Now center of graph. So a vertex whose eccentricity is minimum. Okay, a vertex whose eccentricity is minimum. For example, this is a tree. So what is the center? So first we calculate eccentricity of each vertices. Okay, so here we have calculated eccentricity of A, B, C, D, E and F, which are these. Okay, so which value is minimum? So value of A and B is minimum. Eccentricity of A is 2, eccentricity of B is 2, so center of this tree is 2. Okay, radius and diameter of a tree. So this is very interesting to calculate radius and diameter of any tree or any graph. Okay, so first we will calculate eccentricity of each vertices in a tree. Okay, first we calculate eccentricity and we know what is center. So what is center? As we have a vertex whose eccentricity is minimum. Okay, so now radius. So the eccentricity of center in a tree is called radius of the tree. Okay, for example, we have calculated the center of this tree. Okay, what is the center? Center is A and B. So what is the eccentricity of A? 2. Okay, so radius of this tree is 2. radius of this tree is 2. Now diameter. So length of longest path in a tree is called diameter. So in other words, maximum eccentricity, vertex of maximum eccentricity. So here diameter is 3. So in this tree, diameter is 3 because maximum length is 3. Okay, next, spanning tree. This is very important in chapter of tree. Let G be a simple graph, then a subgraph S of G is called spanning tree. If S containing every vertex of G. Okay, so you remember spanning tree have all the vertices of given graph. Okay, minimum spanning tree. What is minimum spanning tree? So a tree is minimum spanning tree if every vertex included and the total edge weight is minimum, possible that include a path between any two vertices. Okay, so we shall calculate minimum spanning tree. Okay, so about minimum spanning tree, there are two conditions. First condition is every vertex included. Okay, every vertex included. And the total edge weight is minimum. Possible that include a path between any two vertices. Okay, so to construct minimum spanning tree, we shall use three methods. Okay, so first is Kruskal algorithm, second is Prism algorithm, and third is Vertex algorithm. Okay,